Hello viewers, we have a sample question for those prepping for waec, a theory question at that, which is under calculation in heat, and it goes thus. A jug of heat capacity 250 joules per Kelvin contains water at 28 degrees Celsius. An electric heater of resistance 35 ohms connected to a 220 volt source is used to raise the temperature of water until it boils at 100 degrees Celsius in 4 minutes. After another 5 minutes, 300 grams of water has evaporated. Assuming no heat lost to the surroundings, calculate the 1. Mass of the water in the jug before heating. 2. Specific latent heat of vaporization of steam, given that the specific capacity of water Cw equals 1200 joules per kilogram per Kelvin. When you say a question like this, it is something you need to pay attention to details by first and foremost realizing that we have three things here. We have the electric heater, which is a source of heat. We have a jug. We also have water. And generally speaking, according to the principle of conservation of energy, heat energy to be precise, it should be known that the heat lost by the electric heater here must equal the heat gained by the jug and also the water. If I must say again, the electric heater is the hot body here, and the jug and the water are the cold bodies. And heat energy will always be transferred from hot to what? To the cold. Now, to respond to this question at first, the general idea is first to know that heat lost by heater equals heat gained by jug and water. Okay, and here is plus and water. Okay. Alright, now for the electric heater, remember it is coming from an electric source as the question has clearly stated. And before we come back to this, we know that power generally is equal to energy, in this case heat energy, over time. And our interest here, as far as this heat lost by heater is concerned, is the heat energy. So heat energy will be equal to power times time. And from the question, if we look here, the question about the heater, they gave us the resistance, they also gave us the voltage, okay? So, and here again, power generally is IV or I square R, but let me leave it at IV. But they didn't give us current, so for us to get the current, we would be using Ohm's law that says that V is equal to IR. So from Ohm's law, if we make I subject of the formula, it will be V divided by R. So this V divided by R will be substituted back into this power formula. And if we do that, we'll be getting that it will be V over R times V again. So leaving us with what? V squared over R. So what are we saying here? That at this point, our power here would be, our Q here finally would be V squared by R all times what? T. So which is simply V squared T divided by R. So I'll be rubbing off all of this. So at this point here, the heat energy lost by the heater is simply QH equals the heat gained by the jug is QJ plus the heat gained by water is QW. There is V squared T over R. Now then heat gained by jug. Remember, generally from our formula MC delta T, where M is mass in kilograms, C is specific capacity, delta T is temperature rise or change. Then for the jug, I'll be saying MJ CJ delta TJ, and that of water, the heat gained by water, will now be MW TW delta TW. Okay, let's move on and begin to substitute our values. V, according to the question, is what? 220. So it will be 220 square times the time, which, remember, 4 minutes before it was boiled. So 4 minutes here will be 4 times, we must convert it to SI units, which is what? Times 60 to seconds. divided by the resistance R. The resistance R was given as what? 35 ohms. All equal to the mass of... Now, we have a problem here. For the job, they didn't give us the mass, they didn't give us the specific capacity, but they gave us the heat capacity. And I need you to recall that Cp, heat capacity, is equal to what? Mc. So this MjCj will be replaced by Cp, which heat capacity, and that will be 250. So this is 250 times the temperature rise. So the temperature rise is from is between 100 and 28. So the temperature rise there would be 100 minus 28. So I'll close the bracket here. Then plus the mass of the water is what we are looking for in the first question. Times the specific capacity of water is 4,200 times the temperature rise for the jar and the water are the same. Okay? So it would still be 100 minus 28. So if we move on from here, let's get the value for this part of the equation. 220 squared times 4 times 60 divided by 35. That leaves us with 3 equals. So this, the second part now is 250 times 100 minus 28. So that leaves us with 18,000. So this is 18,000 plus this last part now would be 4,200 times 100 minus 28. So if we do that, it will be leaving us with 3 MW. Remember that this MW is an unknown. So at this point, it becomes easier to figure out. So mathematically speaking, it will be that CO2 MW equals minus 18,000. So if we move on, we'll be having this to be 33 minus 18,000. So that will leave us with the fact that MW equals 1 divided by the coefficient of MW, which is 3. So if we do this division divided by 3, that will leave us with 1 kilograms. This is the mass of the water. We've answered the first part of the question. Now we'll be going to the second part, which says that we should get the latent heat of vaporization of the steam. Now to do this, it will continue from here. After another 5 minutes, 300 grams of water has evaporated. So we would assume that the heat energy from the electric heater is used in making the water to evaporate. So we'll be talking about latent heat of what? Vaporization. So because of that, our calculation will go thus with the relation that the quantity of heat from the heater is equal to quantity of latent heat of what? Vaporization. So which will be, our formula still remains V squared T over R is equal to QV, and QV here will be MV LV, where MV is the mass that evaporated and LV is the specific latent heat of what? Vaporization. So let's make LV subject of the formula. LV will be equal to V squared T over V. So let's substitute. V remains 220, which is square, times the time here is the after 5 minutes, so it will be times 60. Remember, it must be converted to SI units, divided by MV. The mass they gave here is 300 grams, which we must convert to kilograms by dividing with 1000. So that will leave us with 0.3 times the resistance remains 35 ohms. So if we do, let's work on this, 220 square times 5 times 60, all divided by 0.3 times 35. Now, let me go through it again. 220 square times 5 times 60, all divided by 0.3 times 35. So if we do this, it will leave us with 0.38 times 10 raised to power 6 joules per kilogram. So this is a typical theory question. Thank you for viewing. Remember to like, share, and subscribe to our channel.